time. Okay. So first is Tatiana. Let's see. Okay, so this is the video that shows that how rig works. Let's look at it later. So this is the video of the animation itself. And I think it's great. As always, I really like the kind of the objects that you placed in the scene. And also the animation itself shows that rig that rig works, that rig is usable. So when you're submitting animations, you don't have to show controllers. You can, but it's not needed. It works even better, like presentation-wise, it works better without them. Okay, so yes, this is great. Okay, so the rig itself, so from the start, we see that it has all the main controllers. It has the global controller that is translatable. There's a controller over the whole wheel for rotation, and there are little controllers for all the cabins. So visually, it looks great. So this is my one comment about this rig, and that's that the cabins start moving, start rotating with the rotation of both of these controllers. So it might seem like a nice feature, right, that they kind of rotate with gravity, but it's better for animation purposes if by default they're kind of stationary. So as the wheel rotates, they rotate stationary with it, if that makes sense. And so I started looking into the file, and so first of all, I like that it's all very clean in the hierarchy. And also it's great that controllers are color-coded, so they're easy to distinguish from one another. And also their shapes are very easy to grab. Now, as for the way these controllers are connected, so this is me already changing some stuff. Actually, let me just undo. Do some changes that I made. Okay, so the way all of these little controllers are connected are, so they're all placed in the groups, right? And they're connected to this wheel core through a parent constraint. And the parent constraint only controls the translation. So we haven't really talked about it, but with parent constraint, you can check and uncheck different parameters, and that will change how they're constrained. So in this case, these groups are constrained through just translation. So one way to change that would be to constrain them with both translation and rotation. So instead of having this kind of constraint, and I'm right now working only with this little, with this cabin at the bottom. So I'm connecting, so I'm clicking on wheel core, clicking on booth, and going constrain parent, and checking all of that, and clicking add. So if this is done for all of them, then you will see that now, if we rotate either this controller or, let's zero this out, or this controller, you will see in both cases, this booth doesn't move. So it stays together with the wheel. And this can be helpful because sometimes an animator might position this wheel somewhere, and let's say they animate something like, say, on the incline. So they want to first position this wheel like this, and they then wouldn't want all the cabins to suddenly move. They would want them to stand straight. So if we want to add this feature for them to kind of be able to move with gravity, we can still do that. So we would want to keep the constraint that you have. And what we can do, we can create two constraints, one for translation and one for rotation. So this one right now is controlling the translation. So let's call it translation parent constraint. Okay, and now we can constrain them again and only constrain the rotation. So it's parent constraint, but we're only using the rotation. And we can rename this one. So this one is translation one, and this one can be called rotation parent constraint.
So like for every booth, there will be two constraints, yes?
Yeah, and this is just an idea. You don't have to change it, obviously, but this is like if you want to go fancy, if you want to give that option. So yes.
Yeah, actually, it was my previous stuff. I tried it, but I don't remember what went wrong. I didn't like the all these booths staying like stuck, and that was a bit kind of trouble. Yeah.
Right. Yeah, and that's why, like, I can sense, I can see that you did it on purpose, right? Because by default, parent constraint does both rotation and translation. So this way, with kind of two constraints, you can have a way to turn it on and off, right? So this way you can give both options to an animator. Because, so this constraint is responsible just for rotation. And you can see that what constraints have is they have a weight attribute. And so right now, if we are to rotate it, this booth you can see stays the same. But if we turn this weight to 0, it will turn off that constraint. And what that will do is it will make the booth rotate as we rotate the controller, right? So that's your original behavior. So this way we can kind of choose whether we want them to follow, and by default they should be following probably, but then we can turn that option off. Now, one thing here is that animator probably isn't going to go find this constraint and turn the weight off. So we would want to make this attribute more usable for them. So one way to do that would be to place it in this main controller. So we can create a new attribute. Let's call it cabin follow. And since it can be only on or off, we can make it a Boolean, or we can make it a float if they want a bit of a control over that transition. Let's make it a Boolean for now. Okay, and hopefully this will work because we're connecting different data types. So the idea here is now that we have this option, we can connect it to that constraint, and we can connect it to all the constraints of all the cabins too. All right, so we have cabin follow, and now we want to find the weight attribute. Here it is. Wheel core weight is 0. So now, as we connect them together, this wheel core will be driven by cabin follow attribute. So now, by default, it's going to be staying here. And if we turn this to 1 to on, yeah, this doesn't quite work. Guess guess it needs to be the same data type. And since weight here, let's see, so it's 1 now, but here it's off. Oh, and it's 0, no, so it should be working. Delete it, okay. Let's see. So here's our main controller. There's our rotation parent constraint. So right now it's off. And translation 1 is on. So this should technically be working. Let's try it with a different data type just to see if that's what was wrong.
The cabin follow attribute that you made. So like if you turn it off and on, which position is supposed to have which behavior?
So it should be acting as the other cabins when it's off, and it should be acting the way it is right now when it's on. Does that make sense? Right, so right now it should have its previous behavior. So let's try. Let's try doing it with the float attribute. Between 0 and 1. Hopefully this will work. Okay. So there's our main controller. Now I lost it. Bounding box. No. Oh, this is the shape. There's the main controller. Okay. Let's move it back here. See, there's our cabin follow attribute. And we want this weight to be 0, and that's our rotation parent constraint. Okay, let's try it now. Yeah, this is still odd to me. And there it is, rotation. Rotation parent constraint. Oh, I'm not connecting it to the right one, am I? It's connected. No, sorry, this is what's constrained, so. Okay, there it is, main controller. It's connected to wheel core. So right now, wheel core is at 0. Okay, yes, it looks like it's, let's see, so when it's at 1, that's the behavior we want. When it's at 0, oh yeah, it looks like it's still acting the same way. But I thought that we changed this. Let's see, maybe it was a wrong parent constraint. So there's the translation parent constraint. Oh, you know what? I feel like I undid too much. Okay, let me just reopen. Where's the? I'll just reopen the file so to make sure that's clean. Sorry, we're spending so much time on this, but I just want to make sure that this works.
It's very important because, you know, do these different constraints influence each other?
So if you have two parent constraints and one is controlling translation and the other one rotation, it should be fine, right? So you shouldn't, so if you have, say, parent constraint that controls both translation and rotation, and on top you have point constraint, you shouldn't do that because then they kind of get into conflicted state. But if you have two parent constraints, one of which for translation, the other which for rotation, it should be fine. Okay, so let's try this again. Okay, let's use this guy. Yeah, but maybe you're right. It might be related to the fact that we have two parent constraints here. Let's see. Okay, so here's one parent constraint that controls only translation, right? And let's add another constraint that will control only rotation. Okay, so at the moment, this is the default behavior. Okay, so if we turn this one off, okay, so this is the translation one. Let's turn it back on. Translation constraint. And this one will be rotation constraint. Okay, so first let's check if this changing of weight works. Okay, so if we change the weight to 0, okay, so they all move together now. If we change the weight back to 1, then it stays together with the wheel. Okay, so now let's try adding an attribute. And I'll try adding a float because then I know that it definitely works. Okay, let's call it cabin follow. Okay, we want to connect this constraints weight. So we want to add this controller here. And there's this wheel core weight. So let's connect it. Okay, so it's right now at 0. Okay, yeah, so it works as expected. So when it's at 0, it doesn't follow the wheel. And when it's at 1, it does follow it. So that's kind of the idea. And you can connect the same attribute to multiple constraints, to the weights of multiple constraints. So if you have those kind of parent constraints for all of them, this one attribute can drive all of them together. Does this make sense? It's kind of a more complex, more advanced, I guess, feature. But you can do that to have those two options. Okay, any questions about any of these?
The question I had was, for example, the order of making constraints. For example, if I tried with main constraint, which is on the floor, and it worked fine, but then I had problems with booth constraint and rotation constraint. If I started with booths, then followed to the control of the rotation of the wheel, and then the last one was this stuff. It was easy, it was better, but then I had troubles with this main constraint. So sometimes I couldn't move the wheel as a whole because it didn't want, and I had to do a strange thing. So I had to take this main control and constrain it to another control group.
Let's see. So you took the main, oh, I see. So there's a control group.
And I don't know if it is right or not.
Oh, I see. And it's constrained to, yeah, so this kind of thing might give you some cycle issues because this main controller, oh wait, so this is main controller? Yeah, so this main controller is the child of controller group, but then it's also controlling it through a scale constraint. So that might give some issues later on. Let's see, what if we try, oh, yes, it looks like it's already.
Yeah, and
yeah,
I found
so that's
this stuff yesterday. Like I have problems with some scaling.
Yeah, so you don't want to do, so you don't want to do that because it's like it's A controlling B, but then B also controlling A. So that creates, usually you will see cycle warnings. Let's see if we got any now. No. So we didn't get any cycle warnings, but it also doesn't work to kind of rescale it back and forth. So let me, yeah, and also in these cases, does undoing it work? No, doesn't look like it. Okay, let's reopen it. Yeah, so to fix that, we would want to remove this constraint. Oh, yeah, there it is. So it gives this cycle warning, cycle on scale constraint. Okay, so let's see. So now we removed that constraint. Yeah, so now it doesn't give issues. We can scale it up and down.
Yeah, but the this yellow control doesn't follow.
Right. Yeah, so there are different ways in which we can deal with these kind of things. So it's already connected to something. Let's see what's it connected to. It's connected to the main controller. Oh, I see. So it's connected through parent constraints. So we can try. So one thing you could do, the simplest thing probably, would be to just parent it. So I would try doing that first. Where is it? Main controller. It's parented. Okay, and that would work. And then you would want to do similar things with all the little ones, right? And if you want to keep, because now these ones don't scale together with everything else, right? But if you want to keep the constraints, you can also do it through scale constraint. But parenting is a bit lighter and just easier to troubleshoot and so on. So yes, so this, so with parenting, these ones we would have to then change the way they're connected. So they wouldn't be connected then to this geometry, but they would be parented through to the overall controller. So you can do it that way, or through constraints. Through constraints would work too. Does that answer your question?
I believe yes.
Okay. Anything else?
No.
Okay, cool. And yeah, so for everyone else too, so with this trick that I showed earlier with having a constraint and then turning off the weight, you can use it in various ways. So one way is for something like this, for a Ferris wheel like this, but you can also use it inside of the character. For example, you can control whether, say, the arm is following the rest of the body of the character, or if it's not. So that can give a lot of interesting features, like you can place the arm somewhere and keep it there, or like the hand somewhere and keep it there, or you can make the hand follow the body. That's one example. Or you can have a hand snap, say, to the hip or something. So that's how it's done. You have multiple constraints and you just switch between them. Okay, so now let's go ahead.
Oh,
oops, excuse me.
Sorry, just to make the final clearance. So can we constrain the controller to controller, or it is not good? We have to constrain controller only to mesh, only to geometry.
Yeah, no, you can constrain one controller to the other, but just remember, so there are multiple ways of structuring a rig. So it's important to be consistent, one, and also it's important to remember how it works in terms of performance. So constraints are much heavier than parenting, right? So it's usually much lighter to keep controllers parented to each other. And also, if they're just parented to each other, it doesn't mess up the hierarchy, right? You can still have your separate controllers group, separate geometry group. Later we'll have joints, so there can be a separate joints group too.
Yeah, and controllers.
Yeah,
and controllers must be clean. Yes, always with zero and no colored marks. So group can be dirty. Group can have all this stuff, but controller must be with zero. Yes.
Yes, exactly.
Okay. Thank you.
All right. Now let's go ahead. No, wait, this one we just looked at. So now Hunter. Okay. So let's check the animation first. Okay, it looks great. And I like the little swing of the boots at the end. Now, as for Rick, so this one I also started looking at earlier, and it has the same issues. So during rotation, you can see the boots, they don't rotate together with the wheel. Also, I can see that there's a slight scaling issue. So when you're scaling, it looks like this controller is keeping the same, it's being kept the same in size.
Yeah, I had some slight issues with the scaling. Like for some reason it was really inconsistent. So I made a separate scaling constraint just to keep it scaling together. But that was just my temporary solution because I wasn't really sure what to do there.
Gotcha. Okay, well, let's take a look. But I like that you added a controller to move all the cabins. So that's kind of one solution to the rotation of the cabins. You can have like either controllers on each one, so that would give kind of the most control to the animator. But you can also give them an option to move them all together.
Depends on how much they pay.
Yeah, that's one way of looking at it. Okay. Let's take a look. Did I open it here? No. All right. Let's take a look. So there is an issue with the scale.
I think that might be an old file that I had.
Okay. Yeah, because this one looks...
It was wonky like before, but then I put a scale constraint on it.
Gotcha. Okay, so this works too. So one thing I would suggest here is to lock...
This is the older file.
Oh, this one's the older one?
Yeah, I re-uploaded
but it works better.
An hour before. I
don't know. Okay, well, you can re-upload the one that you have now, but to me it looks like it works better. At least the scaling works, unlike the demo. So one thing I'm noticing is that there is this part, which is not the part of the controller. So one way you can add it is to parent the shape through parent-r-s. And it looks like you did that. No, it looks like you did that here. Oh, I see. So yeah, so it looks like it's not a consistent shape. So it looks like these are all parented to this shape.
Yeah, that's why I re-uploaded a new file, because I changed the shape of the base controller.
Oh, okay.
And I don't have that file anymore.
You don't have it?
I overrid it because I thought it was completely wrong, so I re-uploaded a new one.
Okay. Okay, so just for everyone else, as a reminder, when you have a situation like this, you can, I'm pressing right now down to get to the shape. And so now I can select the transform node, and I'm saying parent-r-s. So now, if I'm selecting this shape, it selects this main model controller as well. So then we would want to do that with each part. So basically you want to have the shape be part of the transform node. Okay. Yeah, so now for controllers, you don't want to have attributes visible when they're not used. So it would make sense to just lock and hide the ones that are not used, especially for this one. If okay, so they can be rotated in all ways, but you probably don't need to translate or scale this controller. So that's why translation and scale can also be locked and hidden. So just like this, lock and hide selected. Okay. So I like that it's all in one group. And I like that they're all named, so that's great. What is this group? I didn't know.
That was my, like, I failed to make the square all connected together.
I see.
And I didn't know how to like combine it together again, because I was doing the parent -R-S, but it wasn't combining the way I wanted it to.
Oh, okay. Were you like connecting a shape to the transform node?
Yeah.
Okay, but so did it end up working eventually, or?
When I just got rid of it altogether and used a circle.
Oh, I see. So in the later file, just use a circle. Yeah, I would like make sure
Yeah,
to
this
try
is
it
a really,
again.
this is an older file.
Gotcha. Yeah, but I would, if I were you, I'd make sure that you know how to do that, because it kind of gives you an opportunity to create more interesting controllers. Right. Also, if you do want to keep the square, but you don't want to reparent shapes, you can just draw the square with one line just by snapping to the grid. So that's another way of achieving the same thing.
Yeah, I didn't really know which one was the drawing one. This is my second class. I haven't taken the other one.
So the drawing one is here. So in Create, Curve Tools, and you can choose a curve tool. So usually EP Curve Tool is the one that I use. So here you can.
How do I make it close? Like close a face. Like close the two, like, I don't know how to describe it, but like, how do I select one of the older, like the first point and connect it from the last point? Because that's what I was trying to do, but I couldn't close it into a square. So that's
yeah,
why
so you
that
can
squares...
just click. You can just click on the same point, right, like this. So that automatically closes it.
Are you holding down a button to make it snap to a grid? Because whenever I tried that, it wasn't snapping together, and it was like doing little tiny closures or like tiny gaps in between the closures.
Yeah, so I'm holding X. So X snaps anything to a grid. It's a shortcut for this button. So if you hold X while putting points, then they snap to where you're placing them.
Okay, that'd make it much easier.
Okay. All right. So, yeah, so this one, so I can see it's connected through, mostly through parenting, and that's fine. That's a valid way.
Yeah, I changed it later in the new file to a parenting constraint rather than just parenting, so then it wouldn't, so then I could hide it when I did the animation, because when I did the animation beforehand, I couldn't hide the constraints without hiding the whole geometry.
Right.
But then I figured that out like an hour before, and then I was like, oh wait, I gotta go back and fix that. So that's what I fixed mainly, but it's not reflected here on this file.
I see. Yeah, so yes, that's that would be kind of my note, that if you have it separated, as you're saying, visibility, and also it's just cleaner in the
it was. I made it much cleaner when I redid it, so this file just makes me a little embarrassed now.
No, I think overall it's fine. It has all the main functionality, so it's nothing to be embarrassed about. But yeah, but there are some notes that that would make it better. But it seems like you have a good grasp of what those notes are. Okay, so any questions about it, or anything that wasn't quite working while you were working on it?
When I redid the file, I was having trouble with the scaling, and I don't really know how to fix that. Like,
Okay, well,
it works here,
right.
but then it doesn't work when I tried to redo it with the cleaner controls. And like the reason I bet why it's working here is that I'm actually forgetting why it was working better with the scaling. I can't explain it really.
Well, probably because here they're parented, right? So you're kind of
Yeah,
getting
that's probably it.
Yeah, so if you have them in separate hierarchies, the way to connect the scaling is through scale constraint.
Yeah.
So that's one way to do that. Also, in this kind of structure, it's so your global controller right now, it controls this controller, but not this one. So it would make more sense if this controller is also part of this global one, right? Because the idea of the global controller is that, say, Animator gets your rig and they want to place it somewhere in the scene. So they would say move it somewhere here, but they still want this controller to be next to the rest of the rig. That makes sense?
Yep.
Okay. Any other questions?
Not really.
Oh, okay. In that case, let's move on. And let's take a look at Shantae's work. Okay. Yeah, and for this one, I had the same note with the cabins following. I'm not sure if I mentioned it or not with Hunter's, with your file. Okay, so let's look at this one. Let's look at animation first. Okay, great. All of them are rotating. The animation works. It's awesome. So let's there. Okay, now let's see the rig itself. Okay, so the first thing I noticed is that they're not quite aligned. Like when you're rotating the circles, looks like it's not centered. And let's see this. So you chose kind of the same solution here to rotate all of the cabins. That's great. And it looks like it's working with the rotation of the global controller. Let's see. Translation is also working. And the scale is also working. Okay, great. Now let's take a look at the file itself. Okay, so it's all parented under global controller. Okay. See, so there's the scale, the translation. Let's see with the rotation. Yeah, so they look like they're a bit unaligned. And so the same as with other files, it's better if the cabins. Well, actually, let's see. So I see. So they're not moving here, but they are here. Yeah, that I'm more okay with because for this controller, Animator might expect them to kind of move with gravity.
Yeah.
it's supposed to be moving like so they won't like just stay still. So it would move like I guess more realistically. So it will always be upright.
Right. Yeah. So as I mentioned, so it's a good feature to have, but oftentimes, kind of it's better to give animator a control to kind of make it as realistic as they want themselves and kind of add those physics themselves. So that's why I don't think it's necessarily wrong. I won't like downgrade you guys for this particular thing. But just something to keep in mind. Okay. So I feel like it's not aligned with something, probably with the group over this. Well, let's first see. Yeah, let's see. So there's this one and this one there aligned. Let's see what's it controlling. So spinning parts. Yeah, so it looks like the spinning parts pivot. Okay, so the spinning parts pivot is here. Oh no, this controller's pivot also seems to be here. Oh, looks like maybe then it's just not, it's not a circle. That's why it looks like that.
I used the circle, so it should be a circle.
Let's take a look. So let's snap it here. It doesn't look, it looks like it's a little bit offset to the bottom.
Yeah.
Right, because I made just the circle in the center. And let's see, yeah, so their pivot points align. So it looks like maybe you moved it a bit down.
I think when I made it and I scaled it up, I didn't have it directly in the center.
Oh,
so
I see. Yeah, yeah, but this is the kind of thing that is very easy to fix. You can just create a new circle and you can replace this one's shape. So we can again do our parent dash R dash S. No, looks like I did it the other way around, did I? Oh, right, so it changes the shape. Let me freeze the transformations and delete history. Freeze all, delete by type history. Now it should work. There we go. So now we should have two shapes for this controller. Oh, this controller. So there's this shape and this shape. So we can remove this shape and keep this one.
Okay.
So yes, this is just an easy way to fix something if you're not quite happy with the shape of your controller. Okay, So then, yeah, so one other note, so when you have your rig kind of animation ready, you don't want to have any keyframes on it.
I wasn't sure if you wanted the file like with the keyframes in it already or not.
No, so the idea of these submissions is that you submit it kind of as if you were to submit it for an animator, right?
Okay.
And if an animator is receiving a file, they don't want keyframes on it, especially since they will probably be referencing the rig, right? So then they won't be able to easily delete those keyframes if they reference it in.
Okay.
All right, but that's a very minor note. Other than that, yeah, everything looks good. The naming looks good. So same as with the previous file, I would just separate kind of your mesh and your controllers.
Okay.
Because then different features, so then some features are easier to deal with. For example, the visibility, or if say you want to say constrain all the controllers to something, or all the mesh to something. Okay. So that's all I have here. Any questions?
No, I think I'm good.
All right.
Can I ask a quick question about something that you said? Sorry if this is off topic. But you mentioned that they would be referencing the file. Is that so? Like, what's the difference between referencing and importing?
Oh, so referencing you do through a reference editor, and if you reference a rig, you can't change anything in it. So that's why you usually do reference a rig, because you don't want an animator to change some connections, for example. But so you have your reference editor here, and you can create reference, and you can reference a file. Let's say, okay, I want downloads. Downloads here. No. What is the full path to downloads? Copy path. Okay, I'll just find it here. Users, that's me. There it is, downloads. Okay, and I wanted to take one of your Ferris wheel files. Let's say we're taking Shantae's file, then we're referencing it. Continue, so now we have this file, but it's not imported, it's referenced. So we can do multiple things. So if we have multiple files, we can turn them off and on as we want. But then also we have, there are multiple things that we can't do. So we can't, for example, easily delete something. So I just tried deleting, and it said cannot delete because it's a referenced file, not an imported one. And you can see in the outliner, it shows all of these, it shows these kind of little blue rhombus shapes over different objects. So that shows that all these objects are referenced. I think we can still delete the keyframes here. Let's see, no, so we can't even delete the keyframes. Says one or more attributes have referenced. And the same way, we can't delete any connections. So if, say, there is a connection for rotation here, So let's see. Node editor, let's say we want to delete this orient constraint, so we can't do that. Or let's say we want to remove this connection, we also can't do that. Oh, actually we can, apparently. Can we remove this one too? I guess some connections we can remove. But it's better not to do that, right? Because the idea here is that we want this rig to be the same as in the reference file. And what it gives us an ability to do is that Animator can work in this file, and this will be their animation file, and we can work on our rig in our own file. And then once we create some change, they can just reload the reference and the change will be in this rig. So the change will get reloaded as well. So that way we can both work on the same, so we can be working on a rig while the animator is already working on the animation.
So you don't have to finish the rig before it can start getting animated.
Yeah, exactly. So we can, I mean, it's better to have all the functionality in, but we can also add things in, and also Animator can start trying it out, and they can say, oh, I actually want this feature, and maybe we can then add it in. Or sometimes the skinning is not yet done, but Animator can already start animating. And then as they're working with the rig, we can kind of define the skinning and change the weight painting. That makes sense? Okay, but yeah, great question. All right. So, Sophia, let's look at your videos. Okay, so this is the animation. Nice, it all works. Wait, did we not finish it? Let's see. Okay. All right, so this is the rig. So first of all, I like the shapes of the controllers. I like that there's this arrow here and the circle around the wheel is like easy to grab and everything. Okay, so the scale works. That's great. Translation also works. And then the rotation. Okay, and then the rotation of the cabins is both with this controller. Oh, nice. So you have both the controller for all of them and for individual ones. Yeah, so that's really great. So that's kind of an ideal scenario where Animator can move all of them together, but also have kind of more precise control over each one. Okay, that's great. Right, let's take a look at the file. All right, so let's see. So we have translation, scale, oops. They deleted accidentally, looks like it. Okay. So rotation. There's the rotation of the little ones. This rotation, my comment as always with the cabins, but you all heard it before. Okay, and then there's rotation of these cabins. I like that the attributes are locked and hidden for the things that are not needed. With these cabins, it makes perfect sense to have only rotation on X. Sometimes though, with these kind of cases, you might want to add a little bit of other rotations as well for Animator to just a little bit cheat, like some wiggle with these kind of objects. Okay, and let's take a look at how you oops, did I? There we go. Let's take a look at how you set up the rotation. Looks like it's with the groups. That's great. All right, so you have this group that is being all boats gravity. Oh, I see, this is the gravity one. Okay, so you have it be constrained through point constraint, and then the rotation is being controlled by these guys. Yeah, I think this is great. And it's great that you're trying out different ways of connecting. So both through constraints and through just connecting of attributes. Okay, and then, yeah, and the hierarchy is also very clean. So that's great. You have your geometry here, and then you have your controllers here. So that's also good, and the naming looks good to me as well. So one thing I would suggest though with naming is, so if all your controllers have CTRL at the end, it's better if this one also has CTRL at the end too. Then that way it keeps it more consistent. And also, if say you want to create a script that does something with everything that ends with CTRL, that way it would encapsulate all the controllers. Okay, any questions?
No. You actually helped me with everything on the when I sent a plea for help.
Nice. Nice.
Yeah, that.
Okay, good to hear. Yeah, and to everyone, thank you for your questions, and I apologize if I don't always answer them in the timely fashion, but if you struggle with something and if you're stuck, feel free to send me your questions or with screenshots or files. I will try my best to take a look at them. Okay.
I managed to fix my scaling issue, so that's a plus.
Oh, nice.
It was just like a matter of parenting it right.
Okay, good, good, good. Yeah, if you make any changes, you can re-upload. You can re-upload the file. All right, let's see, 7:34. So let's start with our class. All right, so today we'll talk about joints. So do you guys have an idea of kind of what joints are needed for? Why do we need joints in rigging? No? No ideas? Okay, let me ask a different question then. So you saw different rigs. You saw Malcolm, for example. We looked at it together and some of you posed it. And then you also worked on the robot rig at home. So what's the difference between something like a Ferris wheel or a robot and a rig like Malcolm?
Here's joint.
Right, yeah, but so what does it mean? What are the differences in terms of, I guess, how the mesh is structured?
It's one piece.
Right, exactly. So Malcolm is all one piece. So all the deformations are non-rigid. So it's a soft body deformation. Whereas the robot, it consists of multiple pieces, and each piece is rigid, right? So when we rig something like a robot, we don't care. We don't need really joints. We can just create different parts and connect them to each other. So what you created was already a posable character without the need for joints. So that would be kind of the main reason to use joints for deformation. So if we have kind of one mesh of a character, so if we have a character like Malcolm, we can't really separate it. We can't separate him into different pieces, right? It would look kind of like a robot. So another reason to use joints would be for different features that come with joints that can be helpful even for a rigid body character, and we'll take a look at that later, at how they can be helpful. Okay, so first, how do we create joints? So we can create them through, from this shelf. So from the rigging shelf, we can click on this icon, the joints icon, and we can start creating them. Right now, I'm just snapping them to the grid. We can also go to rigging, skeleton, create joints, and we can also go to option box. But with all of these settings, we don't really need to change them. Just the default settings work fine. So the same way, we just can click anywhere in the scene, and that will create our joints. So you can notice that as we're creating these joints, each next joint is visually connected to the previous one. So this visual representation simply means that they're parented to one another. So if we look at them, let's just look at one chain. So if we look at them in this hierarchy, you can see that they're all parented together. So the same way as we can have like separate cubes or spheres parented together. So let's do something like this, just to show that it's the same principle, right? So we can have these cubes parented to one another in the same hierarchy as these joints are, right? So if we parent all these cubes together, they will all rotate, one following another. And the same thing is happening with the joints. So it's the same principle. Now, one thing that differentiates joints from other objects is that they don't have a shape node. So this visual representation that we see is not actually a shape node the same way this cube has a shape node. So if we are to display shapes, you can see these cubes, they will all have a transform node and a shape node. So a joint is not going to have that. So this is just a transform node. So that's why these parts are purely a visual representation. So this kind of pyramid shape that shows that this joint is parented to this one only shows the parenting, nothing else. And an interesting thing here is that if we are to group this joint, joint 2, it will still be parented to this joint, so it shows this connection. And then if we are to group it again, you can see it's still parented to joint 1, but we don't see this connection anymore. So that might be confusing, but it works exactly the same. So it just has 2 groups in between here, but it's still parented the same way. So the reason why I mention it is that at some point during a class, a student kind of showed me a file of his, and he said, "Oh, look, this, like, I have something broken. I don't know what it is. The joints, they're just not connected to each other." When in reality, they were connected just fine, the same way as as they would be, they just had groups in between them. But all that happens is this visual connection was gone, but they were actually parented to each other in the correct manner. Okay, so this is our joint chain. You can see it can be translated, rotated, just the same. So just the same as these cubes can be rotated. So one difference comes with scale. So if we are to scale this cube up, you can see all of these cubes begin to move forward and scale up. Let's change it to 2. With joints, it's a bit different. If we are to scale one joint, you can see this one moves forward, but the rest of them stay the same. And that's a feature of the joint that's called segment scale compensation. And by default, it's on. You can turn it off if you want. Actually, we need to turn it off here. So now you can see they scale up the same as cubes do. But there's really no need to turn it off, so it's better to keep it on. Okay. So this is it, joint chain. Let me see my notes real quick. Okay, so that was one feature that kind of differs joints from other objects. Another feature is joint orientation. So you can see here, we see joint orient and we see certain values. So now rotation of these joints is 0, yet we have certain values on joint orientation. So what that means is it shows how will the joint rotate when it rotates. So at the moment, you can see we can rotate it like this on z-axis, sideways by y-axis, and around itself by x. So that's because it's oriented in a way where x of this joint is pointing towards the child. And that's the default orientation that comes with Maya. And we can see it if in the component mode, we turn on this question mark. So this question mark shows us the orientation of the joint. So you can see x is the axis that points to the child. Right now, z is the axis that points to the side, and y is the axis that points up. But we can change that if we want. We can rotate them some other bizarre ways, something like this, if we so want. And now you can see that if we try to rotate them all together, they won't rotate correctly, right? They will rotate all each in their own direction. So in order to fix that, so at this point we just broke it manually, but it can be aligned wrongly once you create it as well. There you go. So it doesn't always align the way you want it to be. So if you want to change the way it's aligned, you can, so one way would be to do it manually. So you can just select this handle and start rotating it. But that way it's difficult to align it precisely. Another way would be to use a tool that exists exactly for that. And it's a joint orient tool. So under skeleton, you can go to Orient Joint option box, and this will show you the tool itself. So in this tool, so first thing you can do is you can toggle local axis visibility. So it will show you the orientation of this joint, and we can show orientation of all the other joints too. So first thing we want to choose is the axis by which the joint is oriented, and by default it's X, so we can keep it as X. Then secondary axis, it doesn't really matter which one we choose, Y or Z. What's important is where we make it point. So let's say we want to keep Y, and we want Y to always point up, right? So right now, the up for Y is also Y of the scene, right? So you can see here how the scene is oriented. So X is there, Z is towards us, and Y is up. So we can make Y point to the Y of the scene, right? And we can make it minus Y too, then it will point down, or we can make it positive Y. And then we can also orient children of selected joint. And reorient the local scale axis. Sure, we can keep that on as well. So once we hit apply, you can see all the joints are oriented the way we wanted them to. Now we can change it. For example, instead of plus Y, we can change this to minus Y, so this so it gets into reverse. So now if we hit apply, they get rotated by 180. And you can see that the values in joint orientation here also change. So this one is 0, 0 because it's the same as the parent. But this one, instead of Y being 180, now Z is minus 180. But now you can see that this joint didn't get oriented. And so it's pointing now to the opposite direction of this one. So the way to orient it easily, so one way is to just change all these joint orient values to 0. And the other way is to use this orient joint to world. So what it actually means that it orients joint to parent. So if we click this and hit apply, it will keep this last joint's orientation the same as the previous one. So now, if we are to rotate all of these joints, they will rotate as expected. So they will all rotate together. Okay, does this make sense? So far, yeah. Okay. Let's see. So once you orient all the joints with the orient tool, you can then, for example, select all of them and change them a little bit if needed. You can also, while you have these selected, if you want to rotate them just by a bit, you can use a rotate command. And in the command line, so we want to use -R for relative. And we can specify how do we want to rotate. So let's say we want to rotate them by 5 by X. So that will just rotate them all by 5. So this way you can kind of control better by how much you want to rotate them. And oftentimes if you just want to nudge the rotation a bit by 5, you can do that. You can do it through the command line. Okay, so just as a reminder, rotate is the command -R, meaning relative, and then a value. All right. So now important things about joints, when you're creating them, they can have translation values. So we don't want to freeze their translation values. They should have some translation values, but they shouldn't have any rotation values. So all rotation values will be 0. It should be 0. So the idea of joints is that we don't control them through rotation. Rather, the animator controls them through rotation, So that's why we want all rotation to be 0, but we can make orientation whatever we want. All right. So now I mentioned to you guys that joints can give us functionality that we otherwise wouldn't have, that we can't have just through geometry. And one of those functionality is the IK handle. So has anyone heard this term before, IK and FK?
Yeah.
Right, so what do these stand for?
Which point do we fix? So if we move, for example, a hand or an arm, so we can move it from the shoulder and it will follow the body, or we can stack the hand on some object, for example, animate can stack it, and then the whole body can move. Something like this?
Yes, so almost. So yes, that's correct. That's the idea. Just to make sure everyone knows what the letters stand for. So IK is inverse kinematics and FK is forward kinematics. And yes, so as you said, so if, say, a character needs to grab something, we don't want to calculate the rotation of each joint, right? So by default, by default, let's say this is our character's arm. And let's say we wanted to grab this cube. So by default, we would have to rotate each of these joints manually and kind of eyeball when will this touch the cube, right? So this way, doing it through rotations, would be doing it through forward kinematics, right, or FK. So now, if, however, we have a way to calculate what those rotations should be when we positioned the end of this chain here, that would be using inverse kinematics, right, or IK. So in order to create an IK chain, we want to select the joints. Then we can go to skeleton. And there, in here, we can create IK handle. So there's also spline IK handle. So that's for like a specific spline type IK, which we're not going to be using now. So we'll be just using the ordinary IK handle. And we also want to choose the solver. So we can have a single chain solver or rotate plane solver. So, well, let's do single chain solver first. So this is like the very simple IK setup. So you can see now we can select this handle and we can move it exactly to where the cube is. So what it does behind the scenes is it calculates what these rotations are. So it didn't change anything in translation of the joints, it only changed its rotations, but we didn't have to calculate what these rotations should be. So it all got calculated behind the scenes. Right, so as we're moving this, the rotation of these joints changes. So if this is an arm, if this were an arm and we would want to move it around, however, we would probably want some control over how this elbow is moving as well. So, this kind of solver doesn't give us good functionality over it. So it has this twist. It has this roll, but they don't really help us with it. So in order to, let's undo. So in order to have this control over the elbow, we would want a different kind of solver. So we would want to go to skeleton, IK handle, and choose rotate plane solver. So it's rotate plane, so it helps us rotate the plane on which the IK handle is. So we can again select the first joint, then select the last joint, and you can see now it has this circle that is pointing somewhere. So what this allows us to do is to change the plane on which IK handle is positioned. So now if we're to go here and we're to move this twist attribute, you can see the elbow now moves. So if we have an IK arm, we want to give Animator ability to both move this IK handle and move this elbow around. So if we have an IK handle, we probably want to have a controller for an animator to grab and then to move around. So I'll create a simple circle controller for this. So how would you connect IK handle to the circle, to this controller? Any ideas?
Is the IK handle not a controller in itself?
No. So it's not. So all of our controllers, they are NURBS curves. But IK handle is its own type of node. Right? So it can't really be used as a controller. So do you guys have an idea of how we would connect it to a controller?
Maybe we can parent them.
Yeah, parenting is one way. So we can parent IK handle to this controller. And now when we move the controller, the IK handle moves with it. What other way is there?
Constrain.
Yeah, exactly. So that's another way. If we want to keep our hierarchy a bit separate, that would be another way to go. So let's first freeze this controller, edit, delete by type history. And since there is no rotation that we can control on IK handle, we can just point constraint. Right, so now we can move our controller around and you can see the rotation of this arm changes. Now, for the twist of IK handle, so there are multiple ways we can give Animator an ability for this elbow movement. One way would be to create an attribute here called elbow. Then let's clear all of this. And then we can connect it to the twist attribute in the IK handle. So that's the simplest way of controlling it. It's there. 1, 2, 3. There we go. For some reason doesn't. There we go. Okay. So we have our twist and we have our new attribute that we created, so we can connect it to the twist. Right, so now if we change this value, the elbow will be twisting with it. So that's one way, but it's oftentimes not very useful for an animator. An animator would often want to kind of place an elbow somewhere. So they want to specifically say that the elbow should be here. So in order to make that work, so I'm going to disconnect these two and delete attribute, this elbow attribute. So in order to have something to move an elbow, we can create another controller. So we can create this controller here, where the elbow is. And then we want to take it aside a bit. And now what we can do is we can create a special constraint called a pole vector constraint. So it's right here. So you remember we looked at all the constraints, but at the end we didn't talk about the pole vector constraint, and I mentioned that we will look at it later. So this is the time. So this is why it's used. So we select the controller first, then the IK handle, then click pole vector constraint. And now, as we move this controller, the elbow moves with it. So this is kind of a preferred way for animators to work because it's much more intuitive, right? So they can place this controller somewhere and the elbow will follow. Okay, any questions so far?
Why don't we use this controller on the elbow itself? Why do we put it aside?
So we could, right? So we could have it here, but if you have mesh around, then it becomes difficult to see. And also because usually we want it to be kind of more visible in the rig. So that's why conventionally, usually we take it outside so that animator can move it kind of from here. So they can move the elbow, but not have this controller collide with everything else. That makes sense?
The same, yeah, and the same stuff will be with knees, yes?
Yeah, exactly. So knees would have their own pole vector controls and elbows their own. Okay, any other questions about IK setup? No? Okay. Now, let's actually create some mesh here so that it's a bit clearer how it's going to look, in the character. Okay, so say we have this kind of mesh there and this kind of mesh here. So let's say it's a kind of a robot type character. Okay, so now this mesh can be attached to these joints, right? And we can attach it in different ways. We can even just simply parent it, we can constrain it, we can also bind it to them, but we'll talk about binding a little bit later. So at this point, let me just do a simple parenting. And you can see now we have this controller and the mesh moves with our joints. Right, so it's kind of a three-layer structure. Before we had controllers that would control the mesh itself. Now our controllers control the joints, and then joints control the mesh. Okay. So this is the IK handle. This is the IK structure. Now let's look at the FK structure. Let's remove everything we don't need from the outliner, like so. Okay, so this is going to be our IK group. And these are going to be our IK controllers. These are going to be our IK joints. Okay, let's keep consistent hierarchy. IK controllers group. Consistent naming. IK joints. Okay, and this will be our mesh. No, wait, these are the joints. No, I think these are the joints that I just duplicated, right? Yes. Okay. Let's call this IK joints group. All right, so now let's look at a different type of structure. Let's make these invisible. So let's look at an FK structure with joints. So joints are already working in an FK manner, right? Like so. Let's attach mesh to them. But even though we can already rotate joints, we usually don't want to make animators animate through rotating joints, because joints are usually right underneath the geometry. So even if we have just a simple FK rotation, we want to still have controllers for animators to use. So to do that, we can create controllers for each of the joints. Okay, so the first thing is we want to make sure that our joints are oriented correctly. So we should have done it even before we created our IK handle, but these are because after we created them, we didn't move them. So these are oriented fine, but now we want to make sure that our controllers are oriented the same way as the joints are. Because if now we are to constrain the joint through orient constraint, well, this one didn't maintain offset. So let's maintain offset, apply. You can see that the way the controller is oriented is different from the way the joint is oriented. And that makes it difficult for animators to use it, right? Because as they rotate, or let's say as they rotate the joint around itself, they would expect for it to rotate around its own axis, right? For it to be in a more natural manner. So in order for us to do that, before we create a constraint, we want to orient the controller itself. So let's first freeze the translation on the controller. So now we want to orient it to the joint. So you remember that if we try to orient it manually, we will get rotation on it, right? So that's not something we want. So even though this way the controller will be rotating more naturally, we can't keep these rotations on here. So do you guys have an idea how would we make it, or how would we make the orientation of a controller more natural, but at the same time keep these rotations at 0?
Maybe group it?
Yeah, exactly. Yeah, good idea. So we can group it. then we can make sure that the pivot point of the group is at the same place as the joint. Oops. And now we can orient the group to be the way we want it to be. So we could just eyeball it and kind of align it to the joint, but that won't be very precise. So do you guys have an idea of how we can align the group to the joint for it to be more precise? Any ideas?
Something like parent it or...
Yeah, that could work. So we can parent it, right? And then that would show the values that it should have, right? So if we are to parent it, it would change the values. So we would know then that this is the value that it should have. So we can remember that value, then unparent it and place it here. So we could do that, but there's an easier way. We can constrain it, right? So we can constrain it to this joint, but as we're constraining, we don't want to maintain offset, right? So that will snap it, as will snap its rotation to the rotation of the joint. Wait, I think I'm doing it the other way around. So we first want to select the joint, then the group, then we want to snap it. And you can see the rotation values on this group have changed. So now we can break these connections, or we can delete the constraint. There it is. So we can now delete this orient constraint since we were just using it for orientation. And now you can say the group got its values, got the values that it needs to have. So now this group is oriented the same way as the joint is. Right, so now if we're to constrain this joint to the group, so we can go constrain orient, the same, we can maintain offset if we want. So now you can see it orients, it rotates in a much more expected manner, right? So if we rotate it around itself, it rotates more naturally. Okay, so we did that for this joint, and we can do the same thing for our elbow as well. So we can snap it here. Now we want to connect both of them, go constrain, orient. Now we don't want to maintain offset, apply. So that creates this constraint, which we don't really need. We just used it to get these values on this group. Okay, and now we can see it points the same direction as the joint. So now we can constrain the joint to the controller. Right, so now we're adding it. And now if we're to rotate this controller, the joint also, the joint also follows its rotation. So it rotates around itself, it rotates up and down, and it rotates sideways correctly. But now these two controllers are not connected to each other, right? So if we are to rotate this one, you will see kind of this joint will be pointing somewhere where we probably don't want it to point, and this controller is left on the ground. So what we can do now is we can parent the second controller, this elbow controller, to this first controller. And now both of them rotate together. And again, they rotate in an expected way in all directions.
Sorry, and we parent the group. Yes, that we parent the group to the.
Yeah, exactly. Because if we were to parent just the controller, then all of our values will be lost, right? So the group can have all its values, but the controller, we want it to be clean.
And just parenting without parent constraint, yes?
Yeah, exactly, because there's no need here for parent constraint, right? So all controllers will then be in one hierarchy and parented to each other, all of our FK controllers. Okay, and at this point, we would also want to change the naming for everything we created. So in this case, our joints, so we can call this one shoulder FK. This one will be elbow FK, and this one can be wrist FK. All right, so this effector, I think, got left from the IK chain, so we don't need it, we want to delete it. And the mesh as well, so this can be our elbow mesh. Oops. And this can be our shoulder mesh. Okay. So now let's unparent this mesh again. Okay, and let's rename these controllers too. So this will be elbow controller. This one can be shoulder controller. This one can be elbow controller group. And this one will be shoulder controller group. Okay, so now we have, and let's place these ones under our mesh. Okay, so now we have our FK joints. Oh, but this one has rotation on it, so that's not good. Let's fix that. Let's remove the constraint. Let's see to the joint. So when you have situations like that, if you have a rotation on the joint, but you want it to be rather the orientation of the joint, you can freeze rotation on it. Oops, didn't work. Freeze, rotate. Did it give me any errors? Yes. Oh, because we already have another joint parented. Let's unparent this one. Let's freeze rotation. Okay. So this is one thing you can do. So it will change the orientation of the joint if you're freezing it, but it will remove the values you have. Okay, so now we can parent it back. And so now, yeah, so what happens here is we have two hierarchies. We have a joint hierarchy and a controller hierarchy, and both of them work together, right? Because we're constraining the joints to controllers. Okay, let's orient constrain this again. Okay, so now this joint is zeroed out, and these ones are also zeroed out. Okay, and let's check the IK joints. So these ones also are all zeroed out. So let's now name it shoulder, IK, elbow, IK, and wrist IK. Did I call it wrist here? Yes, okay. Okay, so now these can be in its own group, that will be called FK joins group. And these ones can be under FK controllers group. Okay, so now you can see we have kind of two setups. So this one for FK joints and this one for IK joints. Now, sometimes it's okay if the rig has either one or the other. So if, for example, you have a situation where you know character is only going to be grabbing for things, their arms can be just an IK. And if you have a situation where the character doesn't ever need to grab anything, but say they need to always flap their arms, that can be just FK. But oftentimes, we want our rig to have both, right? We want to give an animator an ability to switch between one and the other. So say in one scene, the character is grabbing something or needs to use their arm to, I don't know, to place on a table. But then in the next scene, they're, I don't know, spreading their arms about their, just using gestures while talking. So for something like that, we can have both setups and switch between them, and have a, so we would have a switch that will switch between one or the other. So to do that, we would want to have a third chain, and that will be our bind chain. So that will be the chain to which our mesh is being bound to, and that joint chain will switch in between IK and FK. So let's duplicate it for now. And let's, so we can put BND, for example, for bind, or GNT just for joint at the end. So then we will have FK, IK, and the GNT joint. We don't need these two constraints, so we can delete them. Okay, and now we want this joint to kind of follow either one of the chains or the other chain. Do you guys have an idea of how we could achieve that? No? Okay, so
Through Boolean.
Sorry?
This attribute Boolean, when we can switch it on and off.
Right, yes, so we want, so that's a good first step. So we want some kind of controller, right, that would have an attribute. Let's add attribute, and it will be called IKFK. So we can make it a Boolean, but it's usually a good idea to make it a float, because then the switch can happen more gradually. So I'll make it a float for now. So when you're doing it at home, you can try it with different types. You can try making it a Boolean as well. But you can see the float kind of gives you a bit more functionality. So yeah, so there will, so we can have this kind of attribute. Let's lock and hide everything else. So yeah, so that's a good first step. But how, do you have an idea of how will we connect the joints themselves to each other so they can switch? No, any ideas? Okay, so we can actually do it through constraints. So if you remember during the first class, when we were talking about constraints, or was it the second class? I'm not sure. But when we were talking about constraints, we looked at this kind of example where we had 3 cubes And let's say these two are drivers for this cube. So we can select all three of them. So we start with the outer ones, then the middle one. Then we can go constrain, and let's say parent constraint, add. So now, if we're moving this one, this middle cube moves in between them. And the same thing happens when we move this one. So you might remember from what we talked earlier when we looked at the Ferris wheel and how we can kind of have constraint that we turn on and off. We can do the same thing with this constraint. So you remember on the Ferris wheel, we looked at the constraint, it had a weight, so we turned the weight on and off, and we connected it to an attribute. So this is a very similar principle. So if we're to look at this parent constraint for this cube, you can see it has two weights because it has two cubes controlling it. So if we are to set this weight to 0, then only this cube's weight will be set to 1. So it will be positioned closer to this cube. So in fact, the distance between them will be the same as when we constrain the cubes. So now if we're to move this cube, the middle one will be following, but it won't be following this one at all. But we can do the opposite now. We can change these weights so that this one will have full weight and this one will have no weight to it. And so now this cube will be following this right cube, but not the left one. Right, so we can use the same principle on the joints. So for joints, though, we don't need parent constraints since they only rotate. So we can just use orient constraint. Right, so we will orient constraint the middle joint chain in between the FK joint chain and the IK joint chain. And so just to make clear, so we have the center joint, then two joints on the side. So as this one rotates, if we want, we can switch this joint to follow it. But then if we don't want it to follow IK, we can switch it to follow FK. Right? Does that make sense? As a theory, or not quite?
As a theory, yes.
Okay, well, that's good. That's a good first, that's a good step. And it's a step in the right direction. Okay, well, hopefully as we look at it in practice, it will be clear as well. Okay, so here's our GNT joint. So let's start with the shoulder joint, but we'll want to do the same thing for the elbow joint as well. So we have our FK joints and our IK joints. So the important thing here is to remember in which order we constrain them, because we want it to be done the same way for all the joints. So let's start with IK. So we select our IK joint, then FK joint, then the center joint, the shoulder GNT, and then we can go constraints, orient, apply, and now we can do the same thing for the elbow joint and also apply. So now you can see if we are to rotate this controller, let's turn on IK joints too. So what's happening here is that this joint is being rotated in between these two, right? So let's change this controller's color. Okay, this is the shape. Drawing overrides. There we go. Enable overrides. There, so that we don't confuse it with the other ones. All right. So now you can see this joint chain is being rotated right in between the two. And you can see if we take this orient constraint and we turn off the IK one, for example, it snaps to where the FK joint is. And vice versa, if we are to make this one 1 and FK 0, it will go exactly where the IK joint is. So what we want to do here is we want to connect it, right? We want to connect these weights to the attribute that we have, because we don't want Animator to have to go find those constraints and change the weights. We want both of them to be manipulated by the same attribute. So we can connect it through the node editor. Okay, so the first thing we want to connect is weight of one of them. And it doesn't really matter which one. It will just, it will make it that that weight is going to be 1 or 0 when the switch happens. So let's say 1 means FK, and then we would want to connect it to the FK weight. But if 1 means IK, then we want to connect it to the IK weight. So let's make it, let's make it that 1 is FK. So we want to connect it to shoulder FK. And now you can see that as we turn it to 1, that weight turns to 1 as well. So when it's 0, it snaps to IK. And when it's 1, it goes in the center here. So why does it go to the center when we change it to 1? Why doesn't it go straight to FK? Do you guys have an idea?
You haven't connected the other one?
Yeah, exactly. So this one will always be 1, right? So it's always in between. So the maximum it can be is in between the two. So if we are to manually change this one to 0, it will snap, right? So now the problem we're encountering is that this kind of connection was very straightforward, right? So when this attribute is 1, that weight is 1. When this attribute, IKFK attribute, is 0, the weight of the FK is also 0, right? But with IK, we want it to be the reverse of that. So we basically want it to be 1 minus whatever value that is. So luckily, Maya provides us not only with transform nodes or shape nodes, it also has a lot of utility nodes. And so you might remember in the beginning when we talked about all the nodes, mentioned that there are utility nodes and that we'll be using them for rigging. So one of those utility nodes, utility nodes, they're mostly responsible for math type things. So let's actually look at them on a different example first. So you remember we looked at how we can connect, say, 2 cubes together, right? So p cubed 2 and p cubed 1. And let's say we want p cubed 1 to be driving p cubed 2's translation. Let's say we're connecting their translate x. Okay. So now, if I move p cubed 1 by x, p cubed 2 is x will also change. Actually, let's do it by some other, let's do it by y so they don't snap to each other. Okay, so now, so what will now happen if I move this p cubed 1 upwards?
Another one will follow.
Yeah, exactly. So this one moves up and this one also moves up. So the only thing that happens here is that this value is being fed into the value of p cubed 2, right? So nothing else. This is just a direct connection. So what we can do is we can add another node here in the middle. So one node that we can add is called multiply divide node. So that's the kind of the easiest one to understand, I think. By the way, so in the node editor, you can click tab and start typing and find your node that way. So I want to multiply divide node, this one. So what it does is it allows us to perform either multiplication or division operations. So in the attribute editor, we can see that by default it's set to multiply. And then it takes first input, second input, and it gives the output. So as the first input, we can connect translate y. As input 2, we can change it to say number 2. So what this node will do is it will multiply whatever input we're giving it by this value, by this input 2 value. So now we can connect this input y back to the translate y. So it's the same connection as it was before, but now we have a node in the middle that does this mathematical operation of multiplying by 2. Right? So what will happen now if I move this cube up? What do you guys think? Any ideas? Or if I move it down?
It will move up, but twice the amount?
Yes, exactly. Very good. It doesn't work for some reason. Let's see. But yes, that's what should happen. See, so p cubed 2, translate y. Input 1x, input 2x. Oh, right, because I'm connecting output y. It needs to be output x. All right, so now it will behave that way. So right, so if they're both at 0, so if this one is 0, this one will be at 0 too. But if this one, for example, goes to 1.5, this one will be at 3. Or if this one goes to 4, this one will be at 8. Right, so this is one example of a math node. And so I used this one, this multiply divide node, because it's I think it's the easiest one to understand. It's very simple multiplication math. So in case of our joints, so just as a reminder, so we have this controller, right? Let's call it IKFK controller. And so now we already connected this FK weight, and now we want the reverse value to be connected to shoulder IK weight. Now, in order to get that value, we can use a node that Maya provides, which is called the reverse node. Right, so it does exactly that. It just takes 1 minus the value. So similar to multiply divide node, it has inputs and outputs. But it only has one input because it doesn't need a second one. So we can place IKFK into this input X, and then we want to connect output X to the shoulder weight. And now you can see it snapped to this FK joint chain. So now we can change this value from 0 to 1, and you can see here how the joint moves in between these two. Does this make sense? Yeah. Okay. So now we can do the same thing with our elbow constraint too. So we can add it here. And we can connect the same attribute that we created to the weight here. So we can connect it to the FK. And then through the reverse node, we can connect it to the IK. So you can see the reverse node has 3 inputs, so we can use that. We might as well. So we're connecting it to input Y and then output Y. There we go. Output Y will go to this IK weight. I'm not sure though, did we connect it? Yeah, okay. So it's connected to FK weight and IK weight. So now you can see when we change this to 1, it goes to our IK chain. And when we change it to 0, it goes to our, sorry, the other way around, 0 IK chain and 1 FK chain. So now, so it's not, it might not be very easy to understand how it works without the mesh, but the idea is that the mesh will be connected to these joints. So let's actually bind it. It will be very simple binding process. So we can go to skin, bind skin, since it's just skeleton and mesh, nothing complex. Okay, so what's happening here is that this mesh is now following the our center GNT joints, right? So now at this point, it's in the FK mode, so we can move around and our mesh will follow. But if we turn this to 0, it will be in IK mode. So you see it moved to the IK. So now if we have our IK controllers visible, we can move this IK controller around too. Okay, so at this point, you might notice we have both sets of controllers visible, right? We have our, first, what is this? I don't even remember. We have our FK controllers and IK controller visible. So what would be better here is if different controllers turn on during different during either IK or FK mode, right? So do you guys have an idea of how we could achieve that? No, how would we switch visibility?
I believe creating the same node as we did for switching between the FK IK mode.
Yeah, exactly. So we can use the same exact theory behind this connection, but just connect it to visibility instead. And in this case, we might not even need to create a new node. We might be able to use this one, or to make it cleaner, we can create a new one as well, the same reverse node, right? So you can see there is visibility on each of the NURBS curves. So we can just do direct connection for FK controllers, right? So when there's 0, the visibility will be 0, and when we're in 1, the visibility will be 1 as well. So we have a NURBS circle. There's this visibility. So we can connect it here, and then connect. Oh wait, this was IK controller, wrong one. So let's actually name it. arm IK controller. And these ones, let's call it shoulder FK controller and elbow FK controller. Okay. All right. So we don't want the arm yet. Let's see. We want our FK controller. So let's open it up. Here's our visibility attribute. Let's just do a direct connection. Okay, and the other one got invisible with it since they're parented, because they're parented to each other. Okay, and so now with the IK controller, we want it to be connected through a reverse node. So we might as well use the same reverse node as before. Right, so we're connecting it to input Z, so the only input that was left, and the output Z will be connected to visibility here. Okay, so right now we're in IK mode, so it's set to 0, so we only see the IK controller. And now if we're to switch to 1, to FK, we only see FK controllers. And that's why I also placed this IK-FK attribute on the separate controller, so that, because that's the one that won't change visibility, right? And oftentimes you will see in rigs, you will have this kind of arm structure. And this controller, so sometimes people make it in the shape of letters, IK, FK on top, to show that this is the switch controller. So we can do that by creating text. Let me show you guys. So we can, oh, I don't even remember where it is. I thought it was under create. Maybe here. No, let me check real quick. Create text. Okay, so it should be here. I don't see text. Curve tools? No. Do you guys see text anywhere? Assets? Annotation maybe? Maybe it changed? No, that doesn't sound right. Odd.
You can search the settings using the Help tab, can't you?
You mean here? Well, I'm not sure how it will, whether it will truly help me. No, that's not what I need. Sorry, give me a second. Yeah, I'm looking online. They're saying exactly what I would expect: create and then text. But it looks like it moved somewhere. Let's see, Maya 2019. Oh, create type. Let's see, Maya's documentation gives a video, but where? Okay, so there it is on the shelf, but I wonder where is it in the menu? Oh, create type. But I don't see any type. Okay, so we can get it from here as well. But this now only gives mesh. Okay, so before there was an easier way to change it to curves, to change it to NURBS curves. Let's see. So right now it's set to polygons. Generator, geometry. Oh, create curves from type. There we go. Okay, so that's the way to do it. Okay, let's call it IK FK. Let's make it both capital. Okay, let's create curves. So now we can delete the text and keep the curves. Okay, so this is what I'm used to. So you can create the text that way, and then you want to combine all of the curves into one single object. And probably you remember that you can select the shape of the curve, select an object, and then use the parent command, which is parent -r-s. Okay, it looks like I'm getting an error. Not enough objects or values. Let's try this again. There we go. Okay, so now I want to parent this F letter. And I'm just arbitrarily parenting all of them to the first one, but it doesn't really matter. Okay, parenting this one. And then this one. All right, so this kind of creates one object with all the other ones, with all the shapes being parented to it. So now we can delete history, and we can also remove all these empty objects. Okay, so in fact, it would be better to parent all of them to the controller that we already have. So let's do that. Let's move it here. Let's freeze all, delete by type history. Okay, so now, yes, now it's better to parent them all to this controller we have. So let's do that. Okay, it doesn't want to, it snaps somewhere here. So we might want to, so we might have to reposition it. Let's see, where did it go? Up here. Okay, we'll reposition all of them together then. Now let's parent this one. Oh man, they all go in their own separate ways. Let me undo before we move them. Okay, so now let's try this. At least that they will, if they do move, to be in a more reliable way. Okay, yeah, so they snap here. That's fine. So now parent this one. Okay, so that's also normal. Okay, and the last one, this one. Okay, so now that they're all part of this shape, we can change. Sorry, now that they're all part of this object, of this transform, we can change. We can change the shape by just moving the CVs. Okay, now we can scale it. There we go. Okay, and we don't really need this circle, or we can leave it if we like it, but we don't really need it. So this will be a controller for our switch. So we can do it this way. Another way is to place IKFK controllers for different arms and different legs on one global controller, or sometimes you will have a controller for specifically for switching things. So to switch, say, stretchiness on and off, to switch IKFK, all of that can be on the same controller too. All right. So yeah, so this is just a trick on how you can make like a nice controller with text in it. All right. Another thing we could do here is, so right now these are very basic circle controllers. One thing we can do is for FK, it would probably be easier for animator. So if we imagine that this is our arm, it would be easier for animator to grab them if they're positioned vertically. So we can just grab all the points and rotate them. We can also rotate them through a command, right? Rotate -R, and we want to rotate by Z, so 0, 0, 90. So that again changes where it's rotated. And because we are rotating just the points, the values on the controllers themselves don't change. So this way, this is already making it nicer. So we can also, since these are only controllers meant for rotation, we can lock and hide all the attributes that we don't need. Say scale, we also don't need. Visibility, we probably just want to hide, not lock, because it's connected to this controller. Okay, and now since controllers for rotation are in FK, and we can make them a bit larger, since right now they're kind of almost the same size as the mesh. Let's scale them separately. So this one and this one. Okay, and so now because we're using circular controllers for rotation, we can change the shape of our IK controller to make it clear that this controller needs to be moved. So we can create a cube controller, for example, for our IK. And the way we can do that is by just snapping a curve over the cube. So let's go over again how we can do that. So we can place this cube on a separate layer so that we can see, so that we can distinguish a curve from it. So I put it in R mode so that we can snap to it, but it's a separate color. So now we can go create curve tools. CV curve tool will work here too. So now we can just snap to the points here. Okay. There we go. Are there any sides that are missing? Hard to tell, but I think this one. Okay, I think it's all good now. So we can now delete this cube, delete the layer, and now we have this controller that we can use for IK. And again, we can just parent the shape here. And it's snapped back to the origin, but we can move it back. We can rotate it as well. So now you can see both of these shapes are part of the same controller, but we can delete the circular shape. So now we have a cube controller for translation. So we can lock and hide everything else. Lock and hide selected, and let's just hide the visibility. So now it's very clear that this controller is here just for rotation, and these controllers are only for, sorry, the previous one was for translation, and these ones are only for rotation. So it's easy to distinguish. And if we want to go even further, we can also change the color of these controllers. That will make it even clearer. So we can go into shape, drawing overrides, enable overrides, and let's say we can change these ones to this kind of shade of blue. And then the IK controllers. So since these would be for the same side, we can keep them as blue, but just have different type of blue. Well, this one I think is the same as, let's try to do something like light blue. No, this is a bad color because it's the same as the selection, as one of the, or the constraint color. So let's try something like this. Is that different? Yeah. Okay, so now we can still color code kind of different sides of our arm, but they're still a bit different. Or if we want to make it completely different, we can change it to something like red or purple. Something like this. So that will make it stand out even more. All right, so that's the idea behind the IK-FK switch. So before we go further, oh, and one thing we didn't take into account is the pole vector controller. So pole vector, I don't even see where it is. I might have accidentally deleted it. I have a new keyboard, so I sometimes delete instead of undo on it. Okay, so with the pole vector controller, we also want some kind of specific shape. Let's say the cube shape. And so in this case, what we did with the pole vector controller is we just placed it here and we moved it away, right? And that's because the current IK handle that we have is all placed on the same plane. So having an IK, having a pole vector here is pretty easy. It's pretty easy to place it on the same plane. However, if we have an arm that, say, is placed, okay, let's draw it on the same plane here, but now let's say it's positioned somehow like this. So let's say our character is in an A pose, and that way the arm will be positioned somehow like so. And this way, okay, let's create an IK handle here. So now if we were to create the pole vector controller in the same way, say we're just placing it here and we're moving it away somewhere. Let's even try to eyeball where this angle would be. So if we are now to select this controller and to select the IK handle, and we go constrain pole vector, then you can see these joints moved a bit. So if we're to select the joint itself, you can see it got rotation values on it. So that's because in this case, the pole vector is not placed exactly on the same plane as these three joints, as where these three joints are. So that's why it tries to compensate its rotation. So in order to avoid that, we need to figure out where specifically to place it. So where is the plane of these three joints? And let's undo some more. Okay, there we go. See, okay, so now they're zeroed out. So in order to find it, we can use a trick by creating a mesh. So there is the create polygon tool in the mesh tools. So we can snap it to the joints and thus create a plane for them. So now in the tool settings, we can check normal to move the vertices of this triangle by a normal. And so now if we are to take this vertex out, we know that it stands exactly on the same plane. So if we are now to position, we want to switch the mode. So if we now are to snap this circle here, we can be certain that it's positioned on the same plane as these three joints. So if we now are to create the pole vector controller, the joints shouldn't snap. Okay, let's do pole vector controller. Looked good to me, but let's check. Yeah, so all the rotations are still 0. So that's how it should be. Okay, so I'm telling you all this because you won't always have like this ideal situation of the arm being like exactly parallel to the ground. So it's good to know how to properly position this pole vector controller in any case that you have. Okay, does this technique make sense? Yeah, okay. All right, any questions at all about the IK-FK switch or the arm, this kind of arm rigging? No, okay.
I do have one little question. Obviously you don't want them to influence one another, like you don't want the FK to ruin the IK or vice versa. Why, like, I don't know, I guess, is there a way in which you would, or I guess, is there a reason you would want to make it so that when you move the arm in space and then switch controllers, the other controller has also in the same space? So like, if you're going through animating a scene and you're using the FK controllers and then you want to switch at that point to the IK, do you have to switch and then make the IK joint where you left the FK one, or is there a way where you would make them follow the arm in a sense, like where it is in the scene, and then switch like from a point?
Yeah, good question. So if you have this kind of setup, you would have to manually kind of move your controller to make sure that the joints align, right? So if you don't want to do this manual process of aligning a joint, you would create a script. So a script that would create a switch between IK and FK mode, and that script would align the joints for you. So you wouldn't, so there is no way of making the rig work in a way where they would align, or they would always be in aligned state. But there is a way to do it through a script. You would write it for, say, a specific character or specific pipeline, and that would allow animators to easily switch from one to another. With that said, usually when animators animate, they don't like switching much. They don't like neither using like the scripts nor doing it manually. So what you would usually see is that an animator will just decide that, okay, for this scene, it will all be in IK or it will all be in FK, and they just continue working like that. Because then because if you switch, you have different keys on different controllers, so that can create some confusion. So oftentimes you will see them just go with one setting for the whole shot. Does that answer your question?
Yeah, it does. Thank you.
Okay, good. All right, so then let's move to the homework. Okay, so what you will want, let me copy. What you will want is you will want to use the same robot model from the previous assignment, but this time you will want to create IK-FK switch just the way we did it in class right now. So you will just want to make it for the robot. So one thing you will notice is that the robot's arm is exactly straight, and you can't really make an IK work if your joints are straight. That's why there is a bend in here. So what you can do is you can change the model to give a little bit of a bend there, or you can just ignore that and have a little bit of an offset in your joints. So you can do that too. So you'll want to create the setup. So make sure you pay attention to your hierarchy, to your naming, to the way controllers look. So make sure it's all of them are easy to grab and to use. Also make sure you have the visibility switching between different controllers. So that's the main assignment. Then you would want to record a video that demonstrates the way it works and upload both the video and the binary file. So then there's an extra credit, and that's to rig the other arm as well. Rig both arms. And that's a good, like that's a good way to practice what you learn, to kind of do it for both sides. And there is unfortunately no way to properly mirror the setup, so you would have to recreate it again. But there is a way to mirror joints, so let's quickly look at that. So to mirror joints, so let's say you have a joint chain here, and now you want to mirror to the other side, so you can go to skeleton and mirror joints here. So you can search and replace names. So if, say, you have left on one side, it will change it to right on the other side. Now mirror function will change the joint orientation. So if you choose orientation, it will just keep the orientation as is. If you choose behavior, it will mirror it by behavior. And then mirror across, just the axis that you mirror by. So right now we want to mirror by YZ, so it will mirror to this side. So that's what is chosen. So we're choosing behavior so that behavior is mirrored. And this doesn't matter for us now. So we hit apply. You see joints are mirrored to the other side. So if you decide to do both arms, you can use this mirroring option to mirror joints. And the reason why we're choosing behavior here is, you can see if we want to rotate these two joints, these two elbows, if we rotate them now, so as we rotate them up, both of them rotate up. But you can see that's not really how the rotation should work, right? So if we are to mirror it by orientation, you can see if we were to rotate them now, they're rotating in the same direction, right? So this is what should happen naturally if we were to have just two chains on two sides. But we don't want that, right? We want the mirroring, we want the rotation to happen together, right? So if we're rotating two elbows, we want them to rotate up together and down together. Okay, any questions about mirroring? No, okay, good. All right, so, oh yeah, and any questions about the assignment at all? No? Okay.
I keep doing this. Real quick, the video, it should just show like switching the IK.
Yeah, switching and how
how the movement works.
Yeah,
Or
exactly.
It doesn't have to show how it's set up, like in the outliner or in the note. Like it doesn't have to show the setup, just like that it works.
Yeah, exactly. So just show it that it works, and because the setup we can check in the file itself. All right. Any other questions? Okay,
and the
great.
joints, just a moment, and the joints, when we position them in the arm of the robot, we can snap the pivots, yes?
Yeah.
So that it must be centered.
Yeah, so that's a good question. So there are multiple ways in which you can place joints in the character. So one way would be to draw them in the top view. So you would see your robot, and you can draw them in the top view and then align them kind of to the geometry. And another way would be to do it similar to how you changed pivots to the center. So you can with the cluster or something, you can find the center of geometry and you can place the joints there. So it's multiple ways. You can try different ways and see what works better for that mesh. Okay, anything else?
And as for fingers, because we finish at the wrist, and should we continue with the fingers?
Yeah, I wouldn't worry about fingers because it's a bit, so fingers are a bit more complex, right? So the arm itself is a lot of work. So I would just suggest to focus on that. And then later on, we will talk about fingers. All right. Anything else? No? Everyone good? Okay, in that case, I'll see you next week and have a good week, everyone.